Hello, welcome to another class with me. My name is Ming. Today we look at how we will set up and present a proof by contradiction. Here are our inquiry questions, but we will focus on the first questions in this particular video. So we start by looking at the mechanic of this particular proof. So if we have a statement, if P then Q, for example, if there is a number square root of 2, then square root of 2 is irrational. So here is my statement. If P then Q, so the P part is a number that is the P part is before then, and the Q part is after the then statement. So square root of 2 is rational. So if we want to prove by contradiction, we will assume the implication here to be not true. So we assume not true means the implication is not true means the not of Q in this case. So we can say square root of 2 is rational. And then we work with this assumption until we reach a contradiction. So the justification with this is very simple. That is, for any statement, if P then Q, the statement is also equivalent. If P then Q, this statement is equivalent to not Q implies not P. So in this particular proof, we assume that the implication is not true. That means we have this. So we start with this, and then we want to work towards a contradiction. If the original statement is true, so if we can reach a contradiction that implies not P, then our job is done. So let us look at the example that square root of 2 is irrational. So we will start the proof by writing. Please also make sure that you write this all the time. We want to show that square root of 2 is irrational with a proof by contradiction. So clearly identify what proof we are doing, and then we assume square root of 2 is irrational. So if we assume square root of 2 is irrational, that is, square root of 2 now can be written as, for example, P over Q, where P and Q are integers, Q is not equal to 0, and P and Q do not share a common factor. That means this is the simplest ratio fraction possible between P and Q. So this is what we have. So next thing that we can do is that we can rewrite this as P is equal to Q square root of 2, and then we can square both sides, getting P square equal to Q square times 2. If this is the case, then what we have is that we know P square now is even because it is divisible by 2. And if P square is even, then we also know that P is even. If P is even, then P can be written as a multiple of 2. So P in this case is 2m, where m here is an integer that is not 0. So this is the first part. So if P is equal to 2m, then I can put this back into our original equation here. Right, for example here, substitute P equal to 2m into 1. So right now we have 2m everything square equal to 2q square, which is 4m square is equal to 2q square. So not enough space. I'm going to move it up here. So that is q squared now can be written as 2m squared, which means that q squared is again even, and q should also be even. If q is even, then q can be written as 2n, for example, where n in this case is an integer, but not 0. So if this is the case, then P and Q share a common factor 2. But this contradicts assumption that P and Q do not share a common factor. So now we have our contradiction. Thus, square root of 2 is irrational. So this is our conclusion. But with the proof a contradiction. Alright, so we have to write all of these statements down, and that's it. As simple as that. And thank you.